Hello all my dear students. We are conducting Score Booster series for GATE 2026 examination, and I will be covering Python questions which are included for DA paper. We will be covering numerical answer type questions and multiple select questions, the questions which have multiple answers. So let's start. I have assembled and created questions from very fundamentals like operators in Python, then control structures, then data types. When I say data types, they are advanced data types like set, tuple, list, and dictionaries, and also functions and recursion. What you have to notice, all my dear students here, is that you have to concentrate on the distractors. Actually, there will be a lot of distractors in the question and in the options, and you should not get trapped in those distractors, which will lead you to a wrong answer. So, the only quality that you should have to solve any Python question is to read and understand every statement. See, you should not attack the complete question at once. When it comes to Python, you should take every statement of Python program according to its merit. And after understanding the current line only, you should go to the next line. The first question here is asking us, what is the value of the expression a plus b at the end of the given code? So this is numerical answer type. You have to fill the answer here. So when this program ends, they are asking us what is the value of a plus b. So let's start. The first line in this code is having a is equal to 2 raised to 3 raised to 4. Now you see, a is 2 raised to 3 raised to 4. Now one way of looking at it would be somebody will calculate 2 raised to 3 first. That is 8. And 8 raised to 4, so a will be announced as 8 raised to 4 by someone. Or the other way is 2 raised to 3 raised to 4 will be calculated as 3 raised to 4 first, that is 81. So a will be announced as 2 raised to 81. Now you watch, this second approach is correct. This is how Python calculates raised to. When you have 2 raised to 3 raised to 4, then Python will always solve the last raised to operator. That is, if there are 2 raised to operators, then the second raised to operator is solved first, and then the first one is solved. This is called right to left associativity. And Python treats raised to operator as right to left. Notice, if this question said that a is 2 raised to 3 in the bracket, if the bracket was mentioned properly, then it would be obviously first 2 raised to 3 will be evaluated, that is 8, and 8 raised to 4 would be correct in that case. Because brackets have highest priority, isn't it? But here brackets are not given, then by default, the second raised to operator will be solved first. So, initial value of a is 2 raised to 81. Next line says initial value of b is 0. Now, the while loop, check that the while loop will execute as long as a is greater than b. And if a is greater than b, then these two lines which are indented here, you watch, will be executed repeatedly as long as a is greater than b. Okay, so let's start. If a is greater than b, then repeat, we have said a should become a divided by floor division 2 raised to 27. And second line to be repeated is b is equal to b plus 1. Now clearly first time a is 2 raised to 81 and B is 0. So A is greater than B. So while is true. This line is getting executed. Again you watch. There are two operators on the right side of equal to. Division, floor division, and raise to. Always raise to operator has higher priority than all other arithmetic operators. Of course, bracket has highest priority. But if bracket is not there anywhere in the expression, then raise to will be solved first. So how are you looking at this particular statement? Let's write it over here. A should become A upon. A upon means 2 raised to 81 upon 2 raised to 27. Now 2 raised to 27 will be first evaluated and then this division will be done. It is very easy to see that if you put 2 raised to 27 in the numerator, it will become 2 raised to minus 27. So this ultimately will be 2 raised to 81 minus 27. That will be the value of A, which is ultimately 2 raised to 54. That means A is now changed. A has now become 2 raised to 54. And the next line, we have executed this line. Next line is B is equal to B plus 1. So B should become 1 because B initially is 0. We are increasing B by 1. This happens during first repetition. Check that while has executed first time. Now you should remember that after the first execution of the while loop, you have to go back and ask the condition again. Is this condition still true? Yes, it has to be true because currently you watch A is 2 raised to 54 and B is 1. So A is greater than B. So we are about to do second repetition. While doing second repetition, the same statement A is equal to A upon, but A is now 2 raised to 54 upon 2 raised to 27 will get evaluated. Obviously, this is 2 raised to 54 minus 27, which means A now becomes 2 raised to 27. This is the new value of A. And B is incremented by 1. You watch the second line. B is becoming B plus 1. That means B will become 2 because just in the previous repetition B was 1. Okay. Now we should go back and ask the same while loop. While A greater than B. Yes, A is 2 raised to 27 and B is 2. So A is still greater than B. So we must execute this A equal to line and B equal to line. So we are into third repetition. A should become A upon, but A is already 2 raised to 27 upon 2 raised to 27. Note the denominator here. Denominator in this line, A is already 2 raised to 27, denominator is 2 raised to 27. So ultimately this is going to become 2 raised to 27 minus 27, which is 2 raised to 0, which is 1. Note the value of A now. A has become equal to 1. And there is one more line, B is equal to B plus 1 here, isn't it? In the while loop. So B will now become 3 because B was 2 in the previous repetition. B will become 3. Now when you go back and recheck the condition, look, while will repeat only if A is greater than B. But A has become 1 and B has become 3. So 1 greater than 3 is false. So the loop will break. And the code will end because ultimately after the while loop there are no more statements. And the question asked us, what is the value of A plus B at the end of the given code? Then A is, as you see, A is 1 and B is 3. So the answer would be 4. So what was the distractor over here? The distractor was the first line. If at all, we solved this as 8 raised to 4. 2 raised to 3, that is 8, and 4. Then we would have got initial value of A as incorrect. And then the entire answer would have been wrong, because we would then have repeated while loop wrong number of times. Here the while loop got executed 3 times. Each time, the denominator was 2 raised to 27. So the power of A got reduced by 27 in each repetition. Okay, let's go for the next one. The next question is asking us what should be the initial value of the variable n if the output of the given code is always 2. This is multiple select question. So they are asking us, when you start the code here, the code is given. When you start the code here, what should be the initial value of n? You note that n is getting used in the code. N is getting used here, but it is not mentioned what is n initially. But they have said that the output is always 2. So if you keep n as 2024 initially, if you say n is 2024 and execute this code, will the output be 2? If the output is 2, then this is correct option, because for this value of n, 2024, output is coming as 2. They have said that the output is always 2, correct? Or you can keep n as 1086. Try again with keeping n as 1086. If you keep n as 1086 and execute the code, are you getting output as 2? If you are getting output as 2, then B is also correct. So what is the skill needed here? Every question, check my words, every question of Python that will be asked in your gate paper will require the skill of reading and dry running the code. If you are able to understand each and every statement, then rest is nothing left. Only to track the distractors. Okay. Now one more thing over here, you watch. In this code, there is a for loop given, and this for is having else, you watch. This else is not the else of this if. Check that. The else has been aligned with for. This is a new feature introduced only by Python. This was not there in C, C++ or Java. What is that else exactly is that this else portion, whatever you have written in the else portion will execute only after for loop breaks. That is, when the for loop ends its total repetitions, entire repetitions, then whatever you have written in else will run only once. Only once that else portion will run. And when all the repetitions of the for loop get finished. I'll write it here. See, the else of the for loop, just be careful, not of the if. Else of the for loop runs only once when all the repetitions of for loop are done, or when for loop breaks. But there is a twist here. You see, this else, this else which we are saying, else of the for loop, will not run. Check my words. This else of the for loop will not run if the for loop stops due to break statement. We call it as premature break. Look, you are saying for loop repeat in the range 1 to 3. But if the for loop breaks somewhere in between only, not doing total number of repetitions, premature break it is, then else will not run. I'll first write it and then explain. So else of the for loop does not run if the for loop is stopped due to break. Just a second. Due to break. Premature break, we say. When does the else of the for loop always run? Only once it runs, that too when all the repetitions of the for loop are done, not premature break. Okay? And when does the else of the for loop does not run? If the for loop is stopped prematurely by the break statement. I hope you will pause the video and record this. So, just before reading the code, just make sure what the break here, the else of the for loop means. Okay, the output of the code is always 2, it says. What should be the value of n? Let's keep n as 2024. Okay, so n is 2024. Now the for loop, is going in the range, I is in the range 1, 3. 1, 3 means it will repeat 2 times. Stop value is not included in the range, isn't it? That means I will be 1 and I will be 2. 2 repetitions it will do. And during each repetition, n will become n by 10. So let's do first repetition. When I is 1. N will become n by 10 means n will become 2024 upon 10. Floor division. That means n will now become 202 because it's floor division. Then there is a if statement saying is n less than 10 colon. Now this if will be false, isn't it? Because watch the value of n at the moment. N at the moment is 202 and 202 less than 10 is false. So as this condition is false, break will not run. See, this section will not run, isn't it? Because if is false. Okay. And then we have this else portion of the for loop. This portion I am writing, you see, which is having n is equal to n by 10. Will this else run now? No. This else runs only after all the repetitions of the for loop. So what you did, you took I as 1, correct? First repetition. You executed n is equal to n by 10. So you got n as 202. Then this if was also in the for, isn't it? It was indented in the for. You checked the if and you said if is false, so I am not breaking the loop. And there is no question of reading this else because this else is for this for. And this else will run only after the for ends. So leave this section and go back to for. Repeat the for. This time you are repeating the for I is equal to 2. Correct? Now I is 2 here. Now when I will be 2, you again run n is equal to n by 10. But n is already 202, you watch, n is 202. So n will now become 202 divided by 10. N is 202 divided by 10. That means now n is 20. Not 20.2, it is floor division. Next you will check, is this if true? 20 less than 10, which is false. So again you won't put a break here. Okay? You won't stop the loop because the condition is false. If the condition is true, only then break runs. And then there is no question of executing else because this else is for this for. Okay. Now you will go back to the for and try to repeat, but you have finished all the repetitions. Look, range was 1, 3. You made I as 1, you executed the loop. Then you went back, you made I as 2, you executed the loop. So all repetitions are over. So the for loop is now saying bye. For loop is now finished. If the for loop finishes, Totally, not due to break. Only then else runs. So now else will run because for loop has finished by doing all its repetitions. So this line will run now. N is equal to n by 10. Come on. What is this? N is equal to n by 10. Note n is already 20. During second repetition, n had become 20. So n will become 20 by 10. That means n will become 2. Check the latest value of n is 2. And then after this else executes, that's it. Now the story of the for is over. And now the next line will run, which is written beyond the for. Print n. N is 2. Observe. Isn't it? I'll just take this up, the working. This must be blocking. Yeah. What I was saying is that this else has executed because the loop has executed completely, isn't it? So as the loop has executed completely, else will run and n will become n by 10. Now if n is becoming n by 10, then what was the value of n at the end of this all repetitions? 20. So now n will become 20 by 10, which is n is 2. And then finally we are printing n. So the output is 2. The question is asking, if the output is 2, then what should be the value of n? And A is the correct option. We got the first option correct. Okay. Now, you might then feel, okay, that means if the first digit is 2, it seems, because output is 2. If the first digit is 2, it seems that our option should be correct. And 1086 should be wrong. 24 should be wrong. Who knows, you might be on the correct track. But once you have understood the logic of the question, what it is doing, you tell me. This for loop, takes I from 1 to 2 always. 2 times it repeats. Because for loop is 1, 3. Whatever is the value of n. So I is going from 1 to 2. 2 times it repeats. Every time it divides n by 10 and calculates new value of n. And then checks, is n less than 10? Then it breaks. Okay. So what I was saying, you might think that, okay, that means if the first digit is 2, then the output will be 2. So you might feel A, C and D are correct options. A, C and D because first digit is 2. Correct. Partly correct you might be. And I'm sure you have guessed it right. Okay. But now after executing it for option A, and once we have understood the logic, let's put n here as 1086. The second option. Can n be 1086? This option. Note, I will take 1 and 2. For I equal to 1, n will become n by 10, 1086 upon 10. That means n will become 108. And then we are asking, is this value of n less than 10? No. So break will not occur. And we'll go back to the for, do the second repetition for I equal to 2. For I equal to 2, n will become new value of n 108 divided by 10. So n will become 10. Correct? You note that n is 10, not 10.8. Now we will ask again, is 10 less than 10? Observe. Is n less than 10? 10 less than 10 is false. So again break will not occur. And the for loop will also finish because it has done both the repetitions. With the value of n as 10, the loop will break. And hasn't the loop stopped due to complete total repetitions, not due to break, complete repetitions it has done. So else will execute. Else executes if for loop completes to its entirety, correct or not? And this last else will execute n is equal to n by 10 once again. That is 10 by 10. Correct? That means n will become 1. And ultimately, we are printing n after the for loop. So the output will be 1. That means with 1086, we will not get output 2. They have said that the output is always 2. Correct? No need, surely no need to check it for 2224. Or is it? Let's see what happens when n is 2224. 2224. See, during the first 2 times it will repeat. We are sure I is 1, I is 2. So during first repetition, 2224 divided by 10. So new value of n is 222. And 222 less than 10 is false. So break will not occur. During the second repetition, when I is 2, n will become 222 divided by 10, which is n will become 22. Correct? And then we will be asking, is 22 less than 10? No. So break will not occur. But then the loop will finish, isn't it? And it will finish due to entire repetition, total, all repetitions. So else will execute and n will become n by 10. That means now n will become 22 divided by 10 again. That means n will be 2 and the final output due to this print n will be 2. So A was correct, C was correct. This can be a distractor, 24. When n is 24, you watch. When n is 24, what will happen due to 2 repetitions? Let's see. When, just a second, I will take 1 and 2. So let's do first repetition. Okay. N will become 24 divided by 10. That means n will become 2. And then we are asking, after n becomes 2 here, we are asking, is 2 less than 10? Yes. This condition is true. So break occurs. Break occurs and the loop breaks. Of course, break will pull the control out of the loop. Even out of else. Entire body of the for loop breaks. So else will not run. Why? Because for loop has not finished to its entirety. And then print n will run, where it will print 2. Correct? Although, less number of digits were there. But you see, because 2 is less than 10, break occurred and n is ultimately 2 here. So 2 will be printed. That means A, C and D are the correct options. Okay. So remember, for loop can have else and what are the rules for that. Similarly, while loop can also have else. And same rule. Else of the while loop runs only if complete repetitions are done. And loop does not break due to break. If it breaks due to break, then else will not run. Okay. Let's get on to the next question. It is on functions in Python. Check that functions is one of the most important topics in Python programming, and at least one question will be asked on function. Actually, 2 questions will be asked, but at least one will be definitely asked. And that question will be on recursion. So the question is asking us the value returned by the function f2124. That means we are calling, we are calling the function f by passing the argument 2124. This is the function defined f of n. So ultimately, all of us know that n is the parameter of the function and n will receive 2124. So when the function is called and when it starts, n will be 2124. Now there should be one and only one strategy to solve recursive functions. That is, use pen and paper wisely. Just check. What we will do is, we will show the first call like this. You see, the first call is f of n, where n is 2124. I am showing the value of the parameter. And you literally run each and every line of the code on paper. What happens when the value of n in the function is 2124? Check the first if statement. We are asking, is 2124 value of n less than or equal to 0? Not at all. So it will not execute return 1, but it will go to else. And this line is getting executed. When you know that this line is getting executed on paper or on your scribble pad, you write that line. In short, you write, what it is returning is, check that the function is returning n%n. So let's substitute the value, return 2124%n plus, just check, plus f of n by 10, floor division this is. So plus f of 212, because 2124 upon 10 is going to be 212. It is n upon 10. Now notice that this is clearly recursive function call. The function f is calling itself. So before doing this addition with this value, you should first evaluate this function. So what has happened is f of 2124 has recursively called f212. So you should complete this call. So on the paper, I would show that the function is called again. The function f of n, isn't it? N is the parameter, you watch. N is the parameter of the function. But this time n passed is 212. You clearly observe that the parameter passed to the function f is 212. So you read the function again. Is 212 value of n less than or equal to 0? Not at all. This is false. So else will run, and again this line is running. So my habit is I will write that line over here. Return n%n. What is that? 212%n plus f of, just check this, n by 10, f of n by 10, 212 by 10, that is 21 and not 21.2. Just check, this is again recursive call. The function f212 has called f21. So let's start the function again. F of n is the parameter. Watch, the function f is having n as the parameter. That n this time is 21. Whenever function takes entry, it always checks, is n below 0 or either 0? No, 21 is neither less nor equal to 0. So again else is executed, and that line, return n%n, that is 21%n plus f of 21 upon 10, which is f of 2, not 2.1. Here comes the recursive call again. I'll just scroll up because a few lines you might not be able to see properly. Okay, so some calls are there up. We will scroll down later on. Okay, but now f of 2 is called. This is the recursive call. F of n, where n is 2. Again you watch that 2 less than or equal to 0. Just check the first condition in the function is false. So else is executed, and the same statement executes, which says the function should return 2%n plus f of 2 upon 10, floor division, 2 upon 10 is 0. So f is getting called again, this time with 0 as the parameter. Just check, that's the recursive call, f of n, where n is 0. So when n is 0, the first if will become true. You observe. In this function, n less than 0, less than or equal to 0, n is exactly 0 will become true. So the function will return 1. Just observe, function f0 is now going to return 1. It is returning 1 means this function will end. Why previous functions did not end? Because they made a recursive call. So f2 said, wait a minute, f0 is getting called from my code. F2 says that. So f2 was waiting. Same happened with f21. But f0 was the first function which said it is returning 1. So this function is over, and whenever a function ends, the calling function resumes. Whoever called it resumes, and it will get this value 1 at the call. You see, this is the place where f0 was called. Yes, this function I am talking about. This f0 was called from here, so it will get back 1 here. Value is returned at the call, and now this line return 2%10 plus 1 will execute. Notice 2%10 plus 1. 2%10 is 2, remainder, plus 1. So the function is returning 3. What I am saying is that this function f2 is returning 2 plus 1, that is 3, and it ends. Because it is returning a meaningful value. It is not having any recursive calls now. So the function is now finished. This function is finished, and it has returned 3. Where? Where did it return 3? At the call. Here is the call. 3 is returned here. Yes? Just check F2. We are talking about this function, isn't it? This is just now finished. It has returned 3. 3 will be exactly returned at its call. And now, ultimately, whoever called this function will resume. Correct. So, F21 resumes, saying that it will complete its code. What is the code? Return 21% 10 plus 3. Just observe. It is now returning 21% 10 plus 3. 21% 10 is 1 last digit of 21 plus 3. So it is returning 4. Observe. This function is now over, and calling function will resume. But the function has returned 4. 4 will be returned at the call. F21. This function was called from here. So 4 is returned here. Correct? Now the function F212 wakes up and it says, now I can complete my code. So 212% 10. What's getting executed now is 212. Just a second. 212% 10 plus 4. 212% 10 is 2. Last digit of 212, remainder it is plus 4. So the function is getting over, and the function is returning. The function is returning 6. 6 will be returned at the call. Just check. 6 will be returned here at the call. And now the calling function F2124 will resume, saying it will return the remainder. See, 2124% 10 is 4, last digit. This is 4 plus 6. 10 will be returned. And that's it. The question was, what will F2124 return? And the value returned will be 10. I hope you got that answer before me. Okay. Let's go on for the other one. Again, the question on recursion. The question asked is, what is the value printed by the given code? So you have to fill the NAT, numerical answer type, and notice that there is a function f of a comma b. So there are 2 arguments passed to the function f, and the call is over here. We are printing f1024 comma 10. So obviously, the value of a, the first parameter, is going to be 1024, and value of b, the second parameter, is going to be 10. This is how the function will start, and they are asking what is the ultimate value returned by this function. Okay, so let's start. See, the first function call getting done is f a comma b. I have a habit of writing parameters, and on top of that parameters their values. So a is 1024, b is 10. These are the parameters or arguments, whatever you call them. So in this define function, the first condition is if a is less than b, but that is false. 1024 less than 10 is false. So I'll go to else if, because if the first if is false, only then the next else if runs. If A is greater than B, yes, that is true. 1024 is greater than 10. So this line is running, you see, return 1 plus f A upon B, comma B. So I have a habit of writing that line which is executed. Return 1 plus f of A upon B. A upon B is 1024 upon 10, correct? Comma B. B is 10. So the call is, actually the line is return 1 plus f of 102 comma 10. 1024 upon 10 will be 102, but this is a recursive call. So we should call the function f of A comma B again with A as 102 and B as 10. Correct? So you reread the code again. Is A less than B? Is 102 less than 10? No, false. So LF, we are asking, okay, if this first condition is false, then check is second condition true. Is A greater than B? Yes, 102 is greater than 10. So again this line is running, the same line which got executed for the earlier function. It says it should return 1 plus f of A upon B. 102 upon 10 is 10, not 10.2, comma B is 10. But this is again a recursive call. So we should now call f of A, B again with A as 10 and B as 10. All right then. Okay, we are into the new function. Then in this function with 10 and 10, let's ask, is A less than B? First condition. Is 10 less than 10? False it is. Let's ask LF then. Okay, if A less than B is false, then is A greater than B? Is 10 greater than 10? That is also false. So we land up in last else. Because the first two ifs are false, we will ultimately execute the last else. This is nested if, isn't it? And the function returns 1. So what the function says, because A less than B is also false, A greater than B is also false, I am in last else, and this function is returning 1. Notice this function is now ending. It is not making any recursive call. So the previous function will resume, whichever has called it. And the function has returned 1. 1 will be returned at the call. You watch. Here was the call. F1010 was called from here. So 1 is returned here. That's the way how we will trace back the recursive calls. Now this function wakes up, isn't it? It resumes. Last time it said, no, wait, I am calling F1010, but F1010 has finished and given the control back to 102, 10. Now the function says, okay, I will return 1 plus 1 because I know what is F1010 now. F1010 is 1. So the function returns to 1 plus 1 and this function also ends, giving control back to its calling body, whoever has called it. But the function has returned 2 and 2 will be returned here at the call. Correct? And now this function will say, okay, now I will return 1 plus 2, that is 3. And that was ultimately, this function ends, that was the question, what will be printed by, what will be the value returned and what will be printed by 1024, 10, that's going to be 3. So 3 is the answer to this question. Okay, let's go on for one more. What is the value printed by the given code? Again, recursive function. But notice the first call to the function is fi. And the function is defined as f of a. So a is the parameter. Now this is a typical question which is highly expected. You see, in the previous example, function f, whenever did recursion, called itself only once. Only once, you see, during each return statement. But here you see, in this return statement, there is a recursive call and there is a recursive call. Two recursions are there. I always trace this non-linear recursion, I call it as, multiple recursive calls in the same return statement with the help of a tree. So let's start. The first call is f of a. The function starts with a equal to phi. I hope you got that. A is phi, because you can see that the call is f of phi. So phi goes in a. And then we are supposed to check, is phi, that is value of a, less than or equal to 0? That's false. So we'll land in else. And in the else, this return statement is executed. What is that return statement? Return f of a minus 1, that is 4, plus f of a minus 2, that is 3, 5 minus 2. That means this recursive call is getting done, and this recursive call is also getting done. That means f of a, when a was 5, is about to call the function 2 times. First time with parameter 4 and second time with parameter 3. But both functions cannot run at once. What happens is, because f5 is calling f4 and f3, f4 will be called first. It's not that both functions will start simultaneously. Only one function can run at a time. So first of them will be called. So I will show it like this. F of a with a equal to 4 is running. New function has begun. If a is 4, if the parameter a is 4, again this if is false, a less than or equal to 0. So this else is executed, and what it is doing, it is saying it will return f of a minus 1, that is 3, plus f of a minus 2, that is 2. Now you see f3 and f2, two recursive calls are there. Story started with f5, and f5 said, wait, I will call f4. But there is one more recursive call pending here, which will be done later. But f4 has begun, and f4 has now started calling f3, the first out of the two recursive calls. So we are into the function fa again with a equal to 3. Parameter a is 3. Okay. And again, you see, it will check. Ultimately, each call is checking, is a less than or equal to 0. 3 less than or equal to 0 is false. So it will go to else. And the function is going to now return f of a minus 1, that is f of 2, plus f of a minus 2, that is f of 1. Again, two recursive calls. And f of 3 will give priority to f2 first. The first recursive call. So now f of a, yes, you might have thought of that this is depth first search getting done ultimately. So f of a is 2 now. Again, else will run, obviously. So the function is returning f of a minus 1. Just observe, this line is getting executed. A minus 1 means f of 1, plus a minus 2 means f of 0. Okay, but the function is now calling f of 1. So here is the recursive call, f of a, where a is 1. If a is 1, you observe again this if will be false. This if 1 less than or equal to 0. So else, ultimately else will only run even in this function, isn't it? So what is the function saying? That it is going to return f of a minus 1, that is 0, 1 minus 1, plus f of a minus 2, that is minus 1, 1 minus 2. Okay, so now f of 0 is getting called, f of a where a is 0. This is it now. See, now a is 0. When a is 0, what function says? When a is 0, the function says, or less than 0 also, the function says it will silently return 1. It will not go to else and not make recursive calls anymore. That means as a is 0 here, the function returns 1 and the story ends over here. The function is returning 1 means the function is finished. And 1 will be returned at the call here, isn't it? At the call, 1 here. And ultimately this function is over, so it will give control to the calling body. Who called this f0? This function called, you watch. when f of a, where a was 1 was running, at that time f0 got called. So what the function says, I am returning 1 and let me give the control back to my calling body. Now the calling body will say, wait, I have got one more recursive call pending, f of minus 1. So ultimately, f of a function will start with a as minus 1. But you know, whenever this function is called such that a is less than or equal to 0. Now a is minus 1, isn't it? So it is less than 0. Then the function silently returns 1. So what is f of minus 1 going to return? It is going to return 1 and end. And 1 will be returned here at the call, isn't it? And because the function is over, it will give the control back to its calling body. After all, f of minus 1 was called when f of 1 was running. Now this function will resume and says, okay, now I can return 1 plus 1. Last time I didn't know what are these values. Now they have got evaluated both to 1. So I will return 1 plus 1, that is 2. And the function ends because it is returning a value, that is 2. It is not making any more recursive calls. And 2 will be returned. Look, 2 will be returned back at the call. F of 1 has got evaluated to 2. So this value is 2. And the function resumes. This function resumes because the function f of 1 is over. Okay, what is f of 2 now doing? This resuming function. This will say, wait, my one more recursive call is remaining, f0. But you know, whenever the function is called with 0 or less value, it returns 1. Last time also f of 0 returned 1. Come on, this time also f of 0 will return 1. So while tracing the code, don't waste your time in calling f of 0, going to the function and reading it, but directly you can say this function is 1. Actually, f of 0 will be called. But don't waste your time in tracing that call, isn't it? Because you know that f of 0 is going to return 1. And now ultimately, this function is going to return 2 plus 1, that is 3. And the function will end. Okay. So that means 3 is returned here at the call. F of 2 has got evaluated to 3. But there is one more recursive call in the calling function. We are back to the calling function, f1. Now, no, you should never run this f of 1 again because we have done all the hard work. You can check at the bottom of this tree, f of 1 was called some last time and it got evaluated to 2. You can put the value here. Otherwise, you can call f of 1, then f of 1 will call f of 0 and f of minus 1. Again, it will return 1 plus 1, which is 2. But you have this working over here. So you should say, okay, last time when f of 1 was evaluated, it was 2. So this will also be 2. Then the function is going to return 3 plus 2, which is 5. So the function will now return 5 back at the call. You note f of 3 has evaluated 5 and 5 will be returned at the call. Okay, but now you see f of 4, says I have got one more recursive call pending, f2. I mean, you can call it, but have you done the work of executing f of 2 somewhere before and it was 3? So you can use that value here and save your time. So this is 3. Naturally, f of 4, is going to return 5 plus 3, which is 8. And it will end. 8 will be returned at the call here. This is the call, isn't it? F of 4. 8 is returned. And now the fun starts. F of 3 is still pending, but we have executed f of 3 last time. And the same chain is going to get repeated. So it is going to get evaluated to 5. So look how by maintaining this work on the scribble pad, we are helping ourselves by noticing that f of 3 last time was 5. This time also it should be 5. Now the function f of 5 will return 8 plus 5, which is 13. And that was the question, what will be f of 5? So the answer would be 13 here. This is the way how you know if the return statement is having multiple calls to the function. You should draw a tree-like structure like this, and then you will get the answer very easily. Okay, let's go to the next question. This question is on data types in Python. The question is, which of the given statements is are true in Python? This is MSQ. Okay, so multiple answers might be true here. First question is, set can store a collection of floating point numbers. Can we have a set in Python like this? X is equal to 1.1, 2.2, 3.3 like this? Yes. Set can contain integer values, float values, it can contain boolean, it can contain strings. What can set not contain? By the way, this is true, set can contain float values. You see, set cannot contain a set. That means if I write a set like this, which contains a set like this, 2.2, 3.2. Notice, this is a set, inner set. This set is correct. Set can contain integers. This is an inner set. This set is correct. Set can contain floats. But the outer collection, you see, outer collection is a set here, isn't it? I'll just scroll this up. Outer collection is a set here. Set cannot contain another set in Python. Nested set is not allowed. I hope you're understanding. Okay. Nested set is not allowed, but set can contain floats. That's okay. Okay. And set cannot contain a list. Set cannot contain a list like this. You can't have a list inside a set. Okay. But set can contain tuple like this. Nested tuple. It can contain a tuple. That's fine. And set cannot contain, I'll write this properly, but set cannot contain a dictionary. Just check. 1:100, 2:200. Notice what we have written inside a set. This is a set. Inside a set, we have written dictionary, which is containing key value pairs. So set can contain int, float, boolean, string, tuple. But set cannot contain set itself, list, and dictionary. Remember this rule, okay? So first option is correct. Then option B is float value such as 2.5 can be used as a key in a dictionary. Yes, it is possible. See, why this question might be asked, they want to check whether you know what can be written in dictionary and what cannot be. Ultimately, I am writing a very simple dictionary like this: 1:100, 2:56, 3:65, 4:97. Now, this is the key and this is the value. Here, this 2 is the key, 56 is the value. They are asking, can we have a dictionary where key is a float and they have not asked anything about value? Say value is 100. Is this float allowed at the place of key? Yes. Okay. Float can be a key. So what can be key? What can be used as a key in dictionary? Just check. In a dictionary, key can be int or float or even boolean or string or tuple. But in dictionary, key cannot be, you can't use this as key. Key cannot be list. or guess what? Set or dictionary. Dictionary itself cannot be a key inside a dictionary. Just remember this. So even B option is correct. C option is tuple is mutable collection. You know tuple is immutable. That's a global fact now, isn't it? Once anything is stored in tuple, you can't change it. They are asking tuple is mutable collection. This is false. And set is mutable collection is the fourth option. Yes, set can change. Because suppose if you have a simple set like this, 1, 2, 3. And there is a function called add in set, x dot add. If you say x dot add 4, then value 4 will be added in this set. Now if you print x, print the set was 1, 2, 3. Now it will be 1, 2, 3, 4. That means set has changed. And anything that can be changed is called mutable. Mutable means something which can change. So set is mutable. So A, B, D are correct options. Okay. Let's go on for the next one. Let A and B be number of elements in list X and set Y at the end of the code. So you see X is a list clearly because square bracket is given. Y is a set because it has been created using set function. Then if A are the number of elements in X and B are the number of elements in Y, okay, then what is A plus B? So they are ultimately asking what is the sum of length of X and length of Y, because A is length of X and B is length of Y. Okay, that can be answered only by dry running the code. So what do you have here is X is 1, 2, 3, 1, 2, 3. You know repetitions are allowed in list. List can store repeated elements. And notice this, Y is equal to set X. Y is equal to set X. I'll write it here. Y is equal to set X means we are saying use all values of X. 1, 2, 3, 1, 2, 3. Those are the values of X. And make a new set using those values and store it in Y. So Y should ultimately be a set containing 1, 2, 3. That's it. Because you know repetitions are not allowed in set. So although we are making a set using 1, 2, 3, 1, 2, 3, but repetitions will be suppressed. So why is this set? And now there is a for loop here. How will you read this for loop? For each element in Y. So this E element will be 1 first time. Then the same for loop will repeat with this E element as 2. And next time this element E will be 3. That means the for loop will repeat keeping E as 1, then E as 2, then E as 3. And note what it is doing for every repetition. It is appending that element of Y. E is the element of Y, isn't it? It is appending that element in X. So ultimately after this for loop, you know, X is going to change. All the values of Y will be appended in X. That means X will become 1, 2, 3, 1, 2, 3, 1, 2, 3. Again, all values of Y. Just check my words. Every element of Y is appended in X. And X doesn't happen to have any objection because X is a list and list can store multiple values. Distinct values are not necessary. Repetitions are allowed in list. And now you notice the next for loop. For E in X. That means we are now saying please take every element from list X, isn't it? List X is this latest one. So this loop is going to repeat 9 times. First time E, this E will be 1. Second time E will be 2. Third time E will be 3. Fourth time also it will repeat. E will be 1. Then E will be 2. Then E will be 3. Yes, because we are saying repeat the for every element of X. And we are saying that element which you pick from X should be added in Y. Tell me what will be added? Nothing will be added. Because first time, you know, when E is 1, look, we are looping through X. First time when E is 1, we are trying to add this 1 in Y. But 1 is already there. Note 1 is already there in y, then that repetition will be suppressed. Similarly, next time when e will be 2, we are trying to add this 2 in y. But 2 is also already there, and same thing will happen with 3 and with every element. That means after this for loop, y will remain unchanged. 1, 2, 3. I hope you got that, right? Just a second. Just a second. So, what was the question? Now the code is over. The question is, if A are the number of elements in list X and B are the number of elements in set Y, then what is the value of A plus B? Clearly A over here is 9, number of elements in X. And clearly B over here is 3. That means A plus B, just check, A plus B should be 12. That should be the answer. Correct? So, numerical answer type, this value should be 12. Okay? Right. Let's see this question. Here, value of x is a list, is 10, just check, 10, 1, 12, 13, 7. And we have been given a for loop, and the question is, what is the output of the given code is. Now you see there is one print statement here, which is printing x0 plus x1. Okay, see, it is printing this x, this is 0th element, first, second, third, fourth. And we are printing x0 plus x1. Just observe. What should be the output? If you analyze this particular code, then in the code, let's go dive deeper into the code here. Initial value of x has been noted, okay, and elements also have been shown. Now there is a line, j is equal to length of x minus 1. Just observe, length of x is 5. There are 5 elements. So j will be 4. Length of x, that is 5, minus 1, that is 4. And then the for loop is repeating for I in range len x. See how the for loop is. For I in range len x is 5. This loop is 0 to 4 actually. When you write only one value in the range, then range ultimately starts with 0 because you are not given start value. And stop value is 5, and stop will be always 1 less than whatever you are given. So 0 to 4 repetitions it will be. Correct? So I is going to be 0, 1, 2, 3, 4. You might have thought about the answer already, but I is going from 0 to 4. And during each repetition, you see, during each repetition of the for loop, there is a swap getting done. xi comma xj is getting swapped with xj comma xi. And then j is getting decreased by 1. J is j minus 1. Okay, ready everyone? Let's keep I as 0. And what is j, by the way? Come on, j is 4. Okay, I is 0, j is 4. That means x0 and x4 are getting swapped. xi and xj should get swapped, isn't it? So x0 and x4 are getting swapped. So 7 and 10. These will be the swapped values. And then observe, j is becoming j minus 1 over here. So I am updating j. J is now becoming equal to, j is becoming equal to 3. J is j minus 1. And now we should go back to the for. Okay. That means the loop counter I will become 1. Now I is 1. And what is j? J is 3. That means xi and xj are getting swapped. That means x1 because I is 1 and x3 because j is 3 are getting swapped. x1 and x3 are getting swapped. So 13 and 1 will be as shown. But then j is becoming j minus 1, isn't it? So now j is 2. and the loop will repeat, and observe the loop will make I as 2. Oh, something interesting is happening here. I is 2 now. So now x2, and you observe I has become 2. So x2 and x2 are getting swapped. Okay. That means 12 will get swapped with 12. Very funny, but x2 is getting swapped with x2. And then j will become j minus 1. Correct. But the for loop will repeat, because, come on, you promised that for will repeat for 0, 1, 2, 3, 4, isn't it? So now the loop will take I as 3. It is still repeating. I is 3 now. When I is 3, j is 1. Just observe. When I is 3, j is 1 here. So x3 and x1 will get swapped. xi and xj. So x3 is getting swapped with x1. What is x3? Just observe. x3 is 1. And what is x1? 13. So 13 and 1 are getting swapped. x3 and x1 are getting swapped. Oh, good Lord, what is happening? Whatever swap was done earlier, is getting cancelled. The values have come back to their places as they were. And now j will become j minus 1. J will become 0. Correct. And the loop will repeat, and loop will say, okay, I got one more repetition pending, because I was supposed to go from 0 to 4. So I is now becoming equal to 4. And j has become 0, you observe. So fourth element and 0th element is getting swapped. That means this fourth element, you watch, is 10. Fourth element, and 0th element is 7. So 7 and 10 are getting swapped. Oh, good Lord. Again, whatever happened in earlier passes, is getting cancelled. And 7 and 10 were swapped earlier, but they are again swapped, and they come back to their places. And now enough is enough. For says, I have finished all my repetitions. So I am now closing the for loop. The for loop ends. What have you got? You see, you have got the same list again. List was 10, 1, 12, 13, 7, original list. And you can see the new list is 10, 1, 12, 13, 7. No change. So x0 plus x1 is what they are asking. What is the output? Output should be x0 is 10 plus x1 is 1. So 11 is the answer. Distractor. I told you, distractor. What happens ultimately? We have seen such code earlier, where there is a counter j which starts from the end, because j started with 4 and I started with 0. And then we are swapping xi with xj. Then I increases, j decreases, swap xi with xj. Then I increases, j decreases, swap xi with xj. So ultimately you might feel, oh, the list is getting reversed. Correct? The list is getting reversed. And then if you ultimately came to that conclusion that list is getting reversed, so in your case, x would have been reverse of this, isn't it? Reverse of this. So it should have been 7, 13, correct? And then 12, 1, 10, exactly reverse. Then x0 plus x1 would have been 20, which is wrong. What really happened is I went from 0 to 4 and J also went from 4 to 0. So whatever we did in the earlier pass, got cancelled and we got the same list. Answer here is 11. Whereas you can pause the video and you can check this code. Here, I am going with I in the range len x upon 2. That means you see length of this list is 5, isn't it? And the for constructed over here is for I in range len x is 5 upon 2. 5 upon 2 is going to be 2. So this range is going to be 0, 1. That means now I will go only from 0 to 1, half of the array. And j will start from the end. If you watch, j is beginning with len minus 1, length of x minus 1. Okay. In this case, this list will be reversed. You can check it. So the list will be 7, 13, 12, 1, 10 ultimately after the for. And then we are printing x0 plus x1. x0 plus x1 will be 20 here. Okay. You can just pause the video, take down this question and check. Now I have got one announcement here to do. Just check that ACE is conducting, pre-gate examination. Your 2026 examination is approaching very fast. So we are conducting pre-gate examination, which will give you a feel of gate exam. Okay. And it is that online exam is going to be get conducted on 18th January. And the sessions have, and the papers, which papers and at what time they will be conducted has been flashed over here. You can just register for this examination by scanning this code, okay, on your cell phone and get registered accordingly. One more announcement I have got to do is just check. ACE Academy is conducting revision series. Thorough revision will be done for your respective paper. The papers have been given here. The list of papers have been given. From 10th of January, the thorough revision series will start. You can scan this code and you can register for this revision series also. Well, that's it I have got for you in this particular session of NAT and MSQs for Python. Thank you very much, my dear students.